Right, so we are going to factor these trinomials. For number 37, it's 4x squared minus 5x minus 6. Since the leading coefficient is greater than 1, I'm going to use slide and divide, where I take this 4 and I slide it here and multiply it by the 6. And my new trinomial is x squared minus 5x minus 24. So I have to ask myself, what are the factors of 24 that could add to negative 5? And I have 1 and 24, 2 and 12, 3 and 8, 4 and 6. And I need to make negative 5, so that would be negative 8 and positive 3. So I'm going to do x plus 3 and x minus 8. Now, because I slid and I multiplied, I now have to unslide and divide by 4. So divide by 4, divide by 4. And I need to simplify these if they can be simplified. 3/4 cannot be simplified. 8/4 just becomes x minus 2. And then I need to unslide that 4. So my factors are 4x plus 3 times x minus 2. For number 38, I'm going to use slide and divide since my leading coefficient is greater than 1. Take this 2, slide it to the 15, and I get x squared plus x minus 30. So I need to think about my factors of 30. I have 1, 30, 2 and 15, 3 and 10, 5 and 6. And I need a negative 30 and a positive 1. So I'm going to do positive 6 and negative 5. So that would be x minus 5 times x plus 6. Since when I slid, I multiplied here. Now when I unslide, I have to divide. Divide by 2. See if I can do any simplifying. X minus 5 halves can't be simplified, but this becomes x plus 3. Slide that 2. And I get 2x minus 5 times x plus 3. For 39, I'm asked to do the summation from 1 to 10 of this geometric sequence. Since it's a summation of a geometric sequence, I'm going to use the formula S sub n equals g sub 1, which is the first term, times 1 minus r to the n, all over 1 minus r. So S sub 10 is the first term, which is 4. And I know that 4 is the first term because this exponent is n minus 1. If the exponent was n, this would be the 0 term, but since it's n minus 1, this is the first term. 1 minus 6/5. Now I could, if I wanted to, change 6/5. See, 6 divided by 5 is 1.2. I think I want to use the decimal instead. 1.2 to the 10th power, all over 1 minus 1.2. And go to my calculator. 4 times 1 minus 1.2 to the 10th. And then divided by 1 minus 1.2. 103. It said rounded nearest hundredths, so it's going to be 103.83. Right, very similar type problem. Just this time I'm doing a summation of the first 12 terms for this geometric sequence. This time I'll leave the ratio as a fraction and just show you how I can still do it the same way. So I'm still going to use my formula S sub n equals the first term times 1 minus r to the n, all divided by 1 minus r. So S sub 12 is the first term, which is 8. 1 minus, I've got to protect that fraction with parentheses, all divided by 1 minus 7/5. So I'll put this in my calculator. I've got 8 times, so 8, yep, 1 minus, in parentheses, 7/5 to the 12th power, all divided by, oh, I didn't hit divided by, in parentheses, 1 minus, in parentheses, 7/5, and to the nearest hundredth, that'd be 1,113.88. 1,113.88. So 41 asks us to find the sum of the first 350 integers. So that would be from n equals 1 to 350. An integer is just n. Since each time you go to the next integer, you're increasing by 1. That's an arithmetic sequence. You're adding 1. So we're going to use the arithmetic formula for adding up all the terms. And remember, this means the first term, and this means the last term. So S sub 350 is 350 divided by 2. Always protect fractions with parentheses. The first term would be 1, and the last term would be 350. So I have 350 divided by 2 times 351. Okay, so 350 divided by 2 times 351. Oops, again, I thought I hit times 351. 61,425. 61,425. Number 42 asks us to find the sum of the first 425 integers. So the same thing, from n equals 1 to 425, is simply n. So I'm going to use my same formula, since it's arithmetic. So S sub 425 is 425 divided by 2. The first term is 1, and the last term is 425. So I'm going to have 425 divided by 2 times 426. Oops, I missed. There we go. Okay, so 425 divided by 2 times 426. And I get 90,525. Okay. Last two problems. Right, so we're asked in number 43 to find the 8th term of the sequence 40, 100, 250, 625. I can tell it's not arithmetic because it goes up by 60 and then it goes up by 150. So I'm thinking it's geometric. So in order to find the constant ratio, we always take term divided by previous term, which would be 100 divided by 40, or it could be 250 divided by 100, or it could be 625 divided by 250. They should all be the same if this is geometric. So 100 divided by 40, 2.5. 250 divided by 100, 2.5. 625 divided by 250, 2.5. So 2.5 is my constant ratio. So G sub n is the first term, 40. The constant ratio is 2.5 to the n minus 1. This is n minus 1 because 40 is the first term. So to find the 8th term, I'm going to take 40 times 2.5 to the 8 minus 1. I know that this is 7. So in my calculator, I'm going to do 40 times 2.5 to the 7. And I'm going to write that down exactly because it didn't ask me to round. 24,414.0625. Right, and the last problem, number 44. What is the 12th term of the sequence 8, 20, 50, 125? Again, I can tell this is going up by 16, then by 30, then by 75, so this is definitely not arithmetic. So I'm thinking geometric, I'm thinking find the constant ratio. So I would take 20 divided by 8, or I could take 50 divided by 20, or 125 divided by 50. No matter which of those I use, alright, 20 divided by 8, I have 2.5, 125 divided by 50, again, my ratio is 2.5. So my formula, G sub n is the first term 8, the constant ratio is 2.5 to the n minus 1. This is n minus 1 because this is the first term. So since I'm looking for G sub 12, it's going to be 8 times 2.5 to the 12 minus 1, which then becomes 11. In my calculator, I'm going to put 8 times 2.5 to the 11th power. And I get 190,734 and 8,633 ten-thousandths. I'm going to write that whole answer down. And that's it. We're finished. We're done trig. So exciting. Congratulations.